our website, you can go to the design tool at the top and you click that. And you'll be taken to a login page, which isn't strictly logging you in, but it retains your info, and you should have to log in maybe once a month or so. Profession is, we'll go with engineer for now. Your customer status, I'll be an existing customer. Your first name can be whatever. We have our roof steel deck design tool and our floor steel deck design tool, depending on what you need. Floor steel deck design tool is for composite analysis only. Roof deck covers basically everything else. So even if it's a floor, but you're not using concrete for your strength, I would still consider your roof deck. So going down, just starting with your inputs, your design method, you can switch between either ASD or LRFD, depending on your design approach. I'll stick with, we'll go with ASD for now. For your deck calculation options, you can kind of filter it down, although you should have the ability at any point to change this, but you can have inward uniform loading, uplift uniform loading, roof diaphragm design, or everything. And I'm going to go with everything for now. But if you want to do just inward and uplift, you can select those independently, but we'll stick with all. Your support member material will depend on your building type. Right now we have mainly different grades of steel, so primarily focused on that. For right now, we'll go with A572 grade 50 as a standard. Your support member thickness, you enter that as needed. This value will impact future inputs. So if you have a really thin value, certain fastener types may not be valid anymore because they haven't been rated for a certain thickness. So this will pre-filter some of your fastener options. Your deck end bearing length, which will be dependent on your support type. Interior bearing length, which will be similar, except that will be your interior of the panel fastener type. So this may be something higher, like a 6-inch. Your minimum deck span can be pretty much any value you want, but I would recommend starting at the lower end and maybe increasing as needed. We'll just go with an 8-foot span for now. And then the increments that your table will create. So in this case, you'll have an 8-foot span, a 10-foot span, a 12-foot span, and so on. Your deck category will depend on what you're looking at. For our roof deck, that will cover your standard BN 2 and 3W roof profiles, no composite decks without any concrete fill. Our form deck options, our acoustical deck options, our cellular deck, and our cellular acoustical deck options are all good as well. But just the roof deck option for right now, you'll get all the different deck types. We break it down in terms of larger categories. So 1.5-inch wide rib, that's your standard B deck profiles. 3-inch deep rib is your in deck profiles. Your 2-inch W and 3-inch W, and then our newer deep deck profiles as well are all options. Based on my span, I'm going to go with my N32 profile. Deck gauge, once again, a user choice depending on your anticipated loading, inward and uplift, and that kind of thing. You may want to switch this up, but we'll go with 18 gauge for now. Your deck grade will automatically populate. So if you happen to have a higher grade material, as part of our product offering, this will automatically select what grade you have. And then your end condition is covering if you are lapping the ends of the deck, if you are butting the ends of the deck together, or if one end of the deck will be butted and one will be lapped. And I'm going to go with lapped in this case, but all this impacts will be your diaphragm shear stiffness values. Your support connection types, once again, recalling back up to here that this member thickness will impact this evaluation, but different weld sizes and diameters, arc seam welds versus spot welds, different powder actuated fasteners, and then screw options as well to support. So for right now, I'll go with the 1/2-inch effective diameter arc spot weld. A connection pattern will be up to the user depending on your needed diaphragm shears. I'll go with something fairly standard with a 32-5 pattern. That's 32-inch wide panel, which will change depending on what your deck type is, and 5 fasteners per deck panel. And then For the interior connections, so not the ends of the deck, similar drop-down options, but you can vary it depending on if you have different end supports versus interior supports. But I'll keep it similar for now because that's standard. Your side lap connection type. This also will change depending on what your profile is. So right now I have an N32 profile. If I want to go with a DG N32 where it gives a delta grip option, you can change that. All the options will stay the same if they can be. So if we did not have an 18 gauge option for a DGN, then this would go away. But for now, it's fine. But now our side laps have changed, and now we get a Delta Grip 4 option. And then you also get an additional option for if you want it based on side lap connection spacing or the number per span. So for spacing, you can say a spacing of 12 inches on center. Or if you want number per span, you can make it 3 connections per span, and it'll calculate it differently, but depending on how the user wants it. So I'll stick with spacing for now. Your deflection limit will be user driven. So since this is a roof profile, I will go with an L/240 deflection. That's pretty standard. And then the number of spans we can have will be, say, 3, and I'm going to go with a seismic condition. And then you can scroll back all the way up. And now that we've entered all of our inputs, you get all of your calculation tables, including panel properties, which section properties, yield, strengths, everything related to that. Effective section properties that match AISI S100 analysis. Your inward uniform loading, which includes all of your basically allowable inward loading, roof loading, snow, live, whatever you need. Also including a deflection limit as well, so you can see allowable, factored, and deflection driven, where at the larger spans you're starting to get greater values. And then allowable diaphragm shear values based on the same inputs we included. And then allowable wind uplift loading depending on bending, deflection driven, or fastener failure as well. So this gives you a good idea that if you have a fastener controlled failure versus a bending controlled failure, you may be able to increase your values through different methods. And so that includes your tables, which is probably the meat of what most of you care about. This also gives you total computation outputs, which will give you things like web crippling capacities for your different end and interior connections, your different fastener failure points, some of the different values that go into the actual evaluation itself as part of the AISI S100 and S310, as well as SDI analysis, and gives a little more thorough of a breakdown, but not a ton of additional info. But if you go to the supporting calculations, this gives basically everything else that you might want, where it goes through all of the calculations, including all of the code references and everything that ties into that. And then those values are what feeds into your tables that you had before. And so anytime you need to print, just hit Control P. You get all of your print outputs once it populates everything, all of the inputs you had, all of the table info, all of the specific calculations that were broken down, as well as the full calculation output. And then you can print and save that wherever you need for the end purposes. When you click the floor deck design tool, that'll take you to your floor deck options. Similar inputs to your roof design tool as well. Your design method, either ASD or LRFD. I'll stick with LRFD this time. Your deck calculation options are different, but a similar input with unshored spans, which covers your shoring requirements based on the loading and concrete thickness you input. Vertical loads, which cover your superimposed loads after the concrete has been cured and you have composite action between the concrete and the deck. And then your floor diaphragm capacities, which are also after composite action has occurred. But in this case, we'll go with all. Your support member material, similar to the roof tool, dependent on the user, but all standard steel grades that you may use for structural support steel. So we'll stick with the A572 grade 50. Support member thickness, once again, a standard user input. In this case, I'll set it to 1/4 inch. End bearing length, slightly different variations, but similar input depending on what the user has. So end bearing length I'll set to 3, interior bearing length I'll set to 6. And then the minimum deck span, similar to the roof tool, depending on what you need for standard tables for your superimposed load. So in this case, we'll start with a 5-foot span, increasing 12-inch increments. So 5-foot, 6-foot, 7-foot span. Deck category, different options. There is a note here for the non-composite deck. Please use the roof tool for that because you will not be getting a benefit from the concrete. So you can use all of your analysis in the roof tool itself. But standard composite deck for now. Your deck type will be all of our composite profiles. So same 1.5-inch wide rib, 3-inch deep rib, 2-inch W and a 3-inch W profile, depending on your condition. We'll go with a 2-inch W in our case. Deck gauge, once again, dependent on your typical loading conditions that you might go with, but we'll stick with 20 gauge for now. And then your end condition, you only have the one option on the roof tool because lapping or butting will not make any capacity or stiffness changes based on that input. So in butted for now. Support connection type, similar to the roof tool, slightly different options depending on your support thickness, but you will go with an HSN 24 at this point. And a pattern, similar drop-down menu, but different depending on your profile type. So we'll go with 36.4. And then our side lap options, which have some impact on your diaphragm shear capacity, depending on the profile you chose. In this case, we'll just go with a button punch. And then similar options here with spacing or connections per span, and we'll stick with spacing for now. And you can change that to something as you feel appropriate. So we'll stick with 24-inch on center button punch. The total slab thickness, which will be the bottom of your deck to the top of the slab, will be based on the user input. So we'll go with a 6-inch profile. Concrete unit weight, depending on if you're going with a lightweight concrete, a sand lightweight concrete, or a normal weight concrete. In this case, we'll stick with just our typical 145 PCF normal weight concrete. Your concrete strength, which will be user dependent as well, 3,000 and higher is what our evaluation covers. We'll set it to 4,000 PSI concrete. Our construction live loading, which depends on is standard per SDI, set at these values here with 20 PSF uniform live load, a concentrated line load, which acts perpendicular to the deck span, and then a ponding allowance. And so these values default to what SDI recommends based on your concrete density. But if you have a higher loading, maybe you have heavier equipment on there that you may want to consider, you can increase or decrease these values as you feel appropriate, with the exception of the live loading and concentrated loading, which has a minimum set of 20 and 150 PLF respectively. These also are set to standard SDI limits with an L/180 construction deflection limit for shoring values, a maximum hard set value of 3/4 of an inch, and then a post-construction deflection limit of L/360. You are able to change them, but these default to what SDI recommends. And then you can generate the table for seismic, wind, or a combination. We'll stick with seismic for right now. And then you can go back up to the top, go to your calculation tables, and then you have a maximum allowable unshored span, which gives you all of the available gauge options. And that is to allow you to better optimize design if shoring is more of a controlling factor, but it will bold the gauge that was selected in the inputs tab. And so in our case, we have a 7-foot span for a single span condition going up to an 8-foot 4-inch span for a triple span condition. The superimposed loads have a maximum uniform load, which in our case is capping out at the SDI recommended 400 PSF allowable load or 700 PSF LRFD load for the lower span conditions, but at the higher span, we start dipping into that a little bit. And then a deflection driven case, which in our particular instance does not control for any instance. And then an allowable or factored, depending on user input, diaphragm shear capacity covering all of the spans we selected for our table. And similar to the roof tool, our total computations include all of the higher level numbers that may impact your capacity. And then the supporting calculations give you a full breakdown of all the factors being used, as well as relevant code references and everything that ties into that as well. And so a whole lot to cover, but that gives you the full calculation table and breakdown. And then just like the roof tool, you can do a similar Control P, which will give you a print option that gives you the full print output, including all of your inputs, as well as the tables and all of the calculation related values that you may potentially need. And then you can save that for your calculation report.